Okay. Hello, eighth graders. So, since I'm going to be out today getting stabbed with needles instead of being in class, your instructions for today are going to be included in this video, but I thought we needed to do some review because it's been a little bit of time since you guys practiced with what we're going to be working on today. For the most part, you're going to have just some assignments to work on, but I'm going to go over a little bit of how to do them. So first things first, let's review how to test a triangle. This is something that was actually on your quiz yesterday, and it's something that's going to be on your next quiz because most of you got it wrong. But let's go over how to do this again. So really quick, if we have a triangle that has side lengths of 9, 12, and 15, and that's all we know about it, how can we determine whether this is a right triangle? The answer is to use the Pythagorean theorem. We can determine our A, B, and C value based on the relative size of the triangle sides. Then plug in the numbers and see if the Pythagorean theorem holds true. Now, a lot of people on the test, you were given a question that was basically, how do we determine whether something is a right triangle without being given any of the angles? And a lot of people said, well, if there's a box in the corner, if it has a right angle, then it's a right triangle. And that's true, but we just said if we're not given any of the angles. And if we're not given any of the angles, that would be something like this, where we just get side lengths. We can still determine whether it's a right triangle by plugging the numbers into the Pythagorean theorem and testing them. So if the Pythagorean theorem works, the triangle is a right triangle. So this would have been like the fullest answer you could have possibly given to question 2 on that test from yesterday. Like I said, this will probably show up again on the test that we're going to take later this week. So let's go ahead and test it with these numbers. We have our A, B, and C value. Remember Pythagorean theorem, A squared plus B squared equals C squared. And we need to figure out what is A, B, and C. C is always going to be the biggest value, no matter what. So this is definitely our C. This is going to be A, and this is going to be B because that's just convenient. So we have 9 squared plus 12 squared equals 15 squared. Oh, sorry, got some hiccups. 9 squared is 81. 12 squared is 144. And 15 squared is 225. If we add up our 81 and our 144, we see that it does in fact equal 225. And 225 equals 225. This is true, so this is a right triangle. And we didn't even have to look at a picture. We didn't have to see any kind of angles. We just know this is a right triangle based just on its side lengths. So let's look at a couple more examples. Are the triangles with given lengths right triangles? So once again, I'm going to go through these kind of quick because you guys are going to get lots of practice on this with your homework or your assignment for today. I guess it's not really homework because it's all you're doing for class. So in this case, again, C is always the biggest value, so we can go ahead and label that in all of these, 11, 13, and 9.9. And then we'll go ahead and solve this. So we have 7 squared plus 9 squared equals 11 squared. 7 squared is 49. 9 squared is 81. 11 squared is 121. 49 plus 81, that is equal to 130. Sorry, goes to 130 equals 121. This is not true, so this is not a right triangle. The answer would be no here. 5, 12, and 13. You guys might already recognize this one, but 5 squared plus 12 squared equals 13 squared. 5 squared is 25. 12 squared is 144. And 13 squared is 169. 25 plus 144 equals 169. This one works, so the answer to this one is yes. Now, this is a little trickier. We've got 7, 7, and 9.9. So this would be an isosceles triangle for those of you who paid attention last unit. So we're going to have 7 squared plus 7 squared equals 9.9 squared. Now, these aren't going to be exact, but we're going to get 49 plus 49 equals, and 9.9 squared, let me grab a calculator because I didn't have this in my head, is we end up getting 98.01. When we add these together, we have 98 equals 98.01. Now, this is an interesting one. Realistically, what happens here is this is a rounding difference. So this actually probably is a right triangle. But technically, if you had said no here because it's 0.01 off, you probably wouldn't lose any points or anything like that. On the IXL, they're not going to give you numbers like this. They'll give you very specific ones that are definitely either one or the other. Now, the other thing I want to review today is solving for a side. So hopefully at this point, everybody is comfortable solving for the hypotenuse. So if I give you a squared plus b squared equals c squared, and I tell you that a is 3 and b is 4, hopefully you know how to do this part. You get c squared. We get 9 plus 16 equals c squared. 25 equals c squared. And then we just square root both sides. Directly square roots. Hopefully everybody knows how to do that at this point in time. It's a little bit trickier when we're not given one of the side lengths. So in this case, we're not given b. First thing we need to do, like usual, is identify our a, our b, and our c. This has to be c. So that means this has to be a, and we don't know what b is. So we're going to go ahead and just put these into the Pythagorean theorem to start. We have 15 squared plus, we don't know b, so we'll leave that as a b squared, equals 39 is our c. Then we need to start plugging or solving these out. We get 225 plus, we still don't know what b is, so we just bring this down, equals, and then 39 squared, I should have already had this calculated out, is 1,521. Now here's where things get a little bit trickier. We need to figure out a way to get rid of this 225. Since it's being added to b squared, we can just subtract it. And whatever we do to one side of the equation, we have to do the other. So we bring that over here. 15 or 1,521 minus 225 is 1,296. And then, just like we did with the c squared, we have b squared equals 1,296. So we take the square root of both sides to get b equals 36. So in this case, our answer would be b equals 36. I'll go ahead and go through two more really quickly. Here we have 4. This must be our b since we're not given a. This must be our c. So we can plug these in. We have a squared since we don't know a, plus 4 squared equals 12 squared. A squared plus 16 equals 12 squared. Or sorry, that's 144. I needed that. Let's erase this out. Okay, 144. We need to subtract 16 from both sides. That gives us a squared equals 128. So a must equal, we take the square root of both sides. And we get about 11.3. And that's rounded. But if you plug that into a calculator, you should get something pretty similar. And then this last one, again, we need to identify our a, b, and c. This has to be a. Since we're not given b, this has to be c. So you can plug these in. We have 17 squared plus, we don't know b yet, so b squared equals 40 squared. We square out 17. I don't know what that is off the top of my head. We get 289 plus, we still don't know b yet, so we're going to leave b squared the same. And 40 squared is 1,600. So we need to subtract 289 from both sides. And when we do that, we get 289. B squared equals 1,311. Take the square root of both sides. And we get that b equals 36.2. Again, that's rounded out, but it's pretty close. Okay, hopefully these things all make sense. Now, there's one new thing that we're going to add today, so hopefully you actually watch the end of this video, and that is the perimeter of a triangle. The perimeter of a triangle is really, really easy. It's just like the perimeter of any other shape. It is just equal to the sum of its sides. So in the case of a right triangle where we have a side length of a side length of b, and a side length of c, the perimeter is just a plus b plus c. In this triangle here, we need to solve for b before we can solve this, because we know that the perimeter is going to be a plus b plus c, but we don't know what b is yet. And we're assuming this is the right triangle. So again, we're going to set this up. A, c, a squared, 3 squared plus, we don't know what b is yet, equals 5 squared. This is 9 plus b squared equals 25. Subtract 9 from both sides. B squared equals 16. Square root both sides. We get b equals 4. But we're not done this time. So now we know we have a side length of 3, a side length of 4, and a side length of 5. Our perimeter is all the side lengths added together. So we have 3 plus 4 plus 5, which is equal to 12. So the perimeter of this triangle would be 12. Let's look at one more example. This time we're not given C, so this one is a little bit easier to solve. Let's use this as A and this is B. So 43 squared plus 52 squared equals C squared. In this case, these are big numbers. I'm definitely going to need my calculator here. 43 squared is 1,849. 52 squared is 2,704 equals C squared. Those two numbers added together will get 4,553. These are huge numbers. Equals C squared. And then we just need to take the square root of both sides. And when we do that, we get about 67.5 equals C. Now this, I boxed it, but this is not actually the final answer, because now we have our side lengths. So 43 plus 52 plus 67.5. Because again, we're just adding all of our side lengths together to get the perimeter. 67.5. And when we add all those up, we get 162.5. That is the perimeter of this triangle here. Okay, so that's all the instruction for today. You have the entire rest of the day to work on these two IXLs. They're R4 and R6. There's not a math-based equivalent. The math-based equivalent would make you like answer with proofs for every single step that you did, and we're not going into that stuff. We don't have time because we're a little bit behind, getting close to the end of the year. So we're just going to do the IXLs. They're R4 and R6, and you only need to get them to 70 or higher. If you do need any help with this, hopefully third period, I will be able to come back and start the Zoom meeting. I should be able to after lunch. So I'll be available then to help once you get done with your third period class. And of course, we'll have time, a little bit of time later in the week to do this as well.